Circle.
The tap water just kind of stay together.
Yeah.
And it didn't really melt as fast as the other ones.
Here's soapy water and tap water and salt water. Make sure you tell each other what you're writing.
Soapy water.
Soap water, it's round, like that one.
Yeah.
It looks like Batman.
It looks like Batman. It didn't really melt as fast.
It didn't melt as fast as the salt
Salt
water.
water, yeah. It didn't as the salt water.
The salt water melted really quickly.
Yeah,
Melted. What was the first thing? Melted.
It looks like a circle.
Yeah, circle.
It feels like
Yeah, it feels like a popsicle.
Alright, did everybody get a chance to touch?
yes,
Feels
like a pop.
Okay, what'd y'all observe about tap water? What'd y'all write?
It stayed together and it really didn't melt as fast as the salt water.
Okay, it didn't come apart. What'd you see?
It just stayed together the whole time.
Okay, what about soapy water?
It didn't really melt as fast as the salt water, but it didn't melt as fast as the salt water, but it kind of melted fast as the tap water.
Okay, anything different?
It like melted slowly.
Slowly? Why do you think it melted slower than salt water?
Because the salt water has the salt in it.
Yeah.
So what did the salt do to it to make it melt slower? What do you think?
It
You gotta make a
dissolved.
guess.
It dissolved.
You think it dissolved in the water?
Yes.
The salt did? Okay. Alright, keep going.
Draw molecules inside of the ice cubes in the different states of matter.
You gotta draw them close together.
What are you drawing?
Just close together.
Yeah.
And as a liquid, you could have like some of them like dripping down.
And then gas, we can like draw the ice cube and like stuff that like stuff coming out of it. Okay, which keys are melt?
And then it's the
Okay.
It's the oxygen is and then there's two hydrogen.
Yeah, they're molecules, which is actually
Yeah,
three atoms right there.
This one's 3 atoms make up.
To make up the one molecule of water.
Very good.
This side
So
is like this.
Exactly. Excited. You can write that word in the middle.
okay, why do we think the tap water the salt water was melting first?
Well,
Because it has the space of a disintegrating object, which is salt, which took up space of the water.
Yeah.
H2O.
it might have lowered the boiling.
Yeah, the salt lowered it, so it would boil at a lower temperature.
Like if it was milk on, which made ice cream.
Okay, which cubes were melting first and why?
Yeah.
The salt water. Which cubes melt next?
The soapy water.
The soapy water. And what cubes were the last to melt?
Tap water.
Tap water. I think it was I think it's soapy water that melted last.
No, it wasn't water.
Tap water was dripping out some water when we got it in the corner.
No, but you saw how that when the soapy water got stronger first out of water. There was nothing first before the tap
So
water.
water was like melted water. Tap water. Didn't you see it? It was like,
Well, it was melting faster.
It was melting faster than the
oh
tap
yeah. So yeah.
What is happening to the molecules in the cube? Well, as the molecules heat up, they get excited and start to spread apart.
Yeah.
What is the heat adding to the ice?
Energy.
Energy. And energy does what to them?
Excited.
Very good.
Makes them active.
So let me ask you this. What state of matter is the most excited?
Yes.
Least.
Solid. Since it doesn't have that much heat.
That's right. If y'all were going to add another type of ice cube, what would y'all add? Just to see.
I'll add
Mud water.
Dry ice.
Mud water? Put soil in it?
dry ice.
Yeah. Now is that water? Is that H2O? No, but not sure what it would do when it was heated. I don't know. I know room temperature it dissolves and that releases the smoke. I'm not sure what the heat would do. Y'all have any questions? Y'all getting it?
Yes. Well, we don't have any questions. We seem to be getting it.
Very good. Keep going.
Yes, ma'am.
Faster, I would add salt.
Salt water.
What would happen if we left the cubes on the heat indefinitely? They would eventually turn into a gas and evaporate.
This to have. What causes this to happen?
But the heat melted the solid molecules and it turns to liquid molecules.
Yes. So what is happening to the molecules and cubes?
They
change.
solids molecules.
What causes this to happen?
The molecules are changing because of the heat and they break down into
They're changing because there's like a whole bunch of heat.
Yeah, that's it. The heat melted the solid molecules.
What do you think you could add to a cube to make it melt slower or faster?
Well, to make it melt faster, you can add more heat.
To make it melt faster, you could.
Add more heat.
Yeah.
Or you put salt in the ice.
You can make it cold.
You can just turn the knob.
Or you like put soap in the ice and then you put it in the heater. It might melt faster like the salt water.
What are the states of matter that the cubes are changing from to? Well, it's changing from solid to liquid
To gas.
What happens if them keep on the heat in different?
They would melt.
Well, they'll melt, then it'll,
It would turn into gas.
It'll evaporate.
It would
Then there'll
evaporate and turn into
be
gas.
no more water, and then just be hot pan.
And it would.
You let the cube in the heat and then you fry it. All the way.
What state of matter would the H2O be in at 12 degrees Fahrenheit? Well,
It would be frozen.
solid.
It'll still be a solid.
What state of matter?
Okay.
What state of matter would the?
What number you on?
We're right here. What state of matter would the H2O be in at 37 degrees Fahrenheit?
What do y'all think?
Well,
It would be.
liquid.
It'd be still. It'd be very cold liquid.
Yeah, it'll be a cold liquid.
When does it change?
Well,
At
it changed after 32 degrees.
Yeah.
So which one's 32?
Frozen.
Okay. So what is the coldest the liquid could be then?
Negative.
No.
0.
The coldest a liquid could be.
33.
That's right.
Would start to evaporate at a faster rate than room temperature.
That's not on there. I just made that question up.
What state of matter would the H2O be in at 250 degrees?
Boiling.
No, it'd be gas.
Gas.
Boiling is how you change it from what to what state.
Liquid to gas.
Liquid.
To gas.
Liquid to gas.
What 3 questions you still have about melting ice or states of matter?
You think still fuzzy up there?
Not really.
You think you got it?
Why does the soap water melt? Why does the soap water melt faster than the tap water?
That's a good one. Write it down. You'll have to figure it out as a class.
Well, I wonder why the soap looks just like the tap water.
You couldn't really see much difference. Okay. What'd you say?
And while tap water stays, melt the slow and
Okay. One thing I observed about the tap water was that it was a big chunk of ice. Do you think the size has anything to do with it?
It's like
because the size, I think the size of us falling off the wood and melting is
it's bigger, and so it takes longer to melt.
Okay.
So it would
into the molecules. And the cubes, they are separated. Y'all then. What causes this to happen? They're getting excited. What'd you say, ma'am? They're getting excited? They're getting excited.
What do you think you could add to a cube to make it melt slower or faster?
Salt to make it go faster. Like salt. You could add salt to it to make it go faster. Do you have one more? Salt. You could add salt. What would make it go slower? Making it bigger. Yeah, make it anything in there. Yeah, making it big. It's like the this is What are the states of matter that the cubes are changing from into?
Solid to liquid.
Solid.
And then to gas.
Yeah, solid to liquid to gas.
Like water is captured in the atmosphere, and then the water, but I don't know how you capture.
What would happen if left the cubes on the heat in later? Indefinitely.
They would get to a boiling point.
Yeah.